Hello guys, today we'll be solving this question. Detect cycle in an undirected graph. Given an undirected graph with v vertices and e edges, check whether it contains any cycle or not. And we are given with the adjacency list for I node, and that adjacency list contains all the adjacent nodes to a particular vertex. So we'll start by looking at the example that is given here. We are given with 5 vertices 1, 2, 3, 4, 5, and 5 edges as well. So we are also given with the adjacency list. Now, how do we detect if a cycle has, the undirected graph has a cycle or not? So we start with any source node. Let's say since we are not given with any, we can start with any one of those. And let's say we are starting with 0. What we'll do is we'll go to 1, okay, and we'll mark before going to 1. We'll mark 0 as visited in the visited array. We'll maintain a visited array, and we'll mark 0 as visited, and then we'll go to 1. From here, while performing a DFS traversal, it reaches 0 and 2 at the same point. But we'll check if the node, all the nodes that it can reach to is already visited or not. For instance, at this point in time when from A we are doing the DFS traversal, 0 is already visited. So explode, we have already done DFS on 0. So we won't go back to this, we'll go back to 2. Now, while doing the traversal, if we encounter a node that is already visited, we'll understand that the graph contains a cycle. Now, here's the catch. Only when there is only one possibility wherein the node is already visited, but it is not, the graph might not have a cycle, is when the node that is visited is its parent. For example, from 1 we go to 2, right? Now from 2, if we do a DFS traversal, we can go to 3 or 1, but 1 is already visited. Can we conclude from this point, from this conclusion, that since 1 is visited, now we have a cycle in the graph? No, we cannot, because 2's parent is 1. So we have reached 2 only because we have reached 1 first, right? Because unless and until we explore the parent, we cannot go to its child, right? So we have explored 1 already, and then from there we are going to 2. So at this point in time, we cannot tell that the graph is a cycle. From 2 we go to 3. Okay, 3 will have two possibilities. It can either go to 2 or it can go to 4. Can we conclude from here that since 2 is already visited, so the graph contains cycle? No, we cannot, because it is from 2 that we come to 3, right? So 2 must be visited. So only case when a node is visited and the graph might not have a cycle is when the node that is visited is its parent. I hope you would have got it. Now, if we go from 3 to 4, 4 will have two possibilities, 1 and 3. But the parent of 4 you see is 3. But now when we see, we cannot visit 3 because 3 is already visited and 3 is its parent. But when we from 4, if we go to 1, we see that 1 is visited, but 1 is not its parent, right? 1 is visited, but the parent of 4 is 3. So 1 has been visited by some other node already, or 1 is visited already. So in that case, there is a cycle, and that cycle is at the vertex 1. So this is how we conclude that the graph has a cycle. Let us go to this example. From 1 we go to 2, from we go to 2 we can go to 1 and 3, but since 1 is its parent, we won't visit it. We'll go to 3, from 3 there is no more nodes that we have to visit, and then there is this disjoint component of a single node that is 0. So this graph has no cycle because it returns 0 as false, and we have written 1 as true. So we'll code it down. What we'll do is we'll maintain our visited array, the size v, and we'll make it initialize it to false, and this being a boolean array, will initialize that accordingly. Now what we'll do is we'll iterate from I is equal to 0 to b, and if it is not visited, if not visited of what I, then we call a DFS traversal, passing what? Passing the node I, the visited array, the adjacency list, and yep, I guess this will be fine. But what we do in DFS traversal is, like, the DFS will return if the graph has a cycle or not. So if it returns true that it is having a cycle, will return true in the answer as well, that it has a cycle. And once we check for all the nodes, we'll come out of the for loop and will return false. Now let me code the function down. Private void, bool DFS. What it takes is, it takes a node, and node, it takes the visited array, bool visited, and it takes the adjacency list, which has already been given to us. Fine. Now what we'll do is we'll mark the node that we got, like from where we are starting, as true, and then I guess we'll need another parameter that will be adjacent nodes. The parent of what? The node that we are passing, right? Because we'll have to check if the node that we are visiting, the node that is already visited, is its parent or not. If it is parent, we can skip that. If it is not, then the graph contains a cycle. So the initial for the node that we are starting with, let's say it's 0, it has no parent, right? So we'll mark, initially pass value -1, and yeah. Now what we'll do is we'll do the basic DFS traversal for auto ID in adjacency list of node. If it is not visited, if it is not visited, if DFS of what node. Now what? Now see, we'll pass it for this adjacency list, right? See, for a node 1, the adjacency list of 1 will contain 2, 4, and 0, right? So who's the parent? Parent is 1, and these are the nodes, right? These are the IT, basically the iterators. So for this, the parent, the node itself will be IT, but the parent will be what? Node, right? For auto IT in adjacence of node, this node is the parent, and these are its neighbors. So for neighbors and then parent, we're calling the DFS traversal. We'll pass this visited, and we'll pass the adjacency list, and if it is equal to true, we'll return true. And if it is not visited, I mean if it is already visited, we'll check if is it equal to parent. Like if it is visited, we'll check if it is equal to parent. If it is equal to parent, we'll return false, right? No, what we'll do is if it is equal to the parent, we'll return false. Parent is equal to the node that is id, return true, sorry, return true, and return false here. No, we'll return false, right? And yes, okay, yep. If this is not, if it is true, if parent is not equal to the id, return true, and else it is false. Yeah, this should be. Yep, I hope you would have understood the approach, and yep, we'll meet in the next one. Thank you.